In this video, we are going to use the law of conservation of energy to calculate the final speed of an object. So the question says your task is to defend a castle from attacker. You have a catapult with which you can lob a rock with a launch speed of 14.2 meters per second. From the courtyard over the castle walls on the attacker camp in front of the castle at an elevation of 7.2 meters. What is the speed with which a rock will hit the ground at the attacker's camp? So let us first sketch the problem. Let this be your courtyard. In the height at which the courtyard is at, I will call that height as y0, y0. Now you launch a rock from here. It follows a projectile path and it hits the attacker camp somewhere around here. We call this height, let's say y. And the distance between y and y0 is 7.2 meters. That's the height difference. We launch the rock with an initial velocity v0 of 14.2 meters per second. So I will write here v0 is 14.2 meters per second. We need to find what is the final velocity at the position here, at the point here, v. What is v find? Now, according to law of conservation of energy, we say that the total energy of the system always remains constant. That means total energy at this point must be equal to total energy at this point here. Let me call this point 1, the initial point of launch, must be equal to total energy at point 2, my final point where the rock lands. Now, total energy is sum of kinetic plus potential energy. So kinetic plus potential energy at the initial point must be equal to kinetic and potential energy at the final point. We are going to use this rule to calculate the final velocity. So let me write that down here. According to law of conservation of energy, kinetic plus potential energy at initial point must be equal to kinetic plus potential at the final. We know that kinetic energy is half mv squared. So for initial point, I will write that as v0 squared. And potential is mgh, where h is the height at which your object is raised. For the initial point, that height I will take as y0 equal to half mv final square plus mgy, which is the height at the final point. Now, since m is present on every term over here, I can cancel that. So we cancel off the m here. And we rewrite the equation. v0 squared by 2 plus gy0 equals v squared by 2 plus gy. Now I need to solve this equation to rearrange them in terms of v square. If you do not wish to rearrange the terms over here, you can always use shift solve to get your answer. If I want to rearrange them, I would go step by step. First, let me get rid of this 2 because my intention is to find v square, not v squared by 2. So I will get rid of this 2. Since 2 is divided in the terms with v, I will multiply by 2 throughout. So when you multiply by 2, you get v0 square plus 2gy0 equals v square plus 2gy. Whichever term contained 1 over 2 will be cancelled and the rest of the terms will be multiplied by 2. I want v square over here, so I must get rid of 2gy. Since 2gy is added here, when I move it to the other side, I have to subtract it. So I will move it. I will rewrite the expression as v square equals v naught square plus 2gy naught. And since I'm moving 2gy on the other side, this plus will become minus 2gy. Then to find v, we will take the square root of the whole term, square root v squared plus 2g is common in these two terms. So when I look at the two terms over here, 2g is common here. So I will take that outside. I will take it as common. And then put a bracket, write y0 minus y. Now we can substitute our values here to get the final answer. So I will substitute v equals square root. Initial velocity is 14.2 plus g is 9.81. Y minus y0 is 7.2. Y0 minus y, because that's the height difference that they have given me. And when you substitute all of this, you get your final velocity as 18.517, which you can nearly write as 18.5 meter per second. Now this rule over here, this expression that we arrive at for velocity, this is an important expression, this term over here. Whenever you have any question where an object is falling or an object is thrown between two height, or you need to calculate the final or initial velocity between any two height difference, you can always use this velocity, which I like to call as impact velocity. Impact velocity means what impact will an object have when it is falling over a certain height and when it hits the ground. So anytime you have an object which is falling over a certain distance and the question has given you distance and not time, like in case of free fall motion or in case of an object rolling down an incline, in any such situation when they have given you a height difference and you have been asked to calculate the final velocity, we use this rule. If you can remember this rule, you can directly use it. So you can write this as v equals square root v naught square plus 2g y minus y naught, where y minus y naught is the difference in the height between 2 points, difference in the distance between 2 points. And in a lot of cases, your initial velocity can be 0. Like if this was free fall motion, where an object is falling from a certain height. Generally in free fall, the initial velocity at this point, we take it to be 0. So in whichever cases the initial velocity is 0, this expression becomes 2g y minus y naught. So it will be very useful if you can remember this expression for velocity. In situations where you have to calculate the final velocity whenever an object is traveling over a certain distance. They give you difference in height or difference in position values when an object is moving instead of time.